We have an important term in this lesson, conjecture. Conjecture is an opinion or theory without complete evidence. So it means that you think something's true, but you really need to gather more data to prove that it's true. Example, Leia is leading a group of girls selling Girl Guide cookies. She conjectures that families with more children will buy more boxes of cookies based on the first 3 houses they visit. So in the first house, there's 0 children, and they bought 1 box of cookies. In another house, there's 1 child, and they bought 3 boxes. And in another house, there's 2 children, and they bought 4 houses. Leia plans to visit the houses in her neighborhood with the largest number of children first to maximize cookie sales. Is Leia's conjecture supported by the data? Okay, so there's really only 3 data points here, but let's have a look and see. So let's make a quick scatter plot. I don't think we even really need to because there's not too much data. Okay, so let's say the number of children is the independent variable. 0, 1, 2, 3. And the boxes of cookies is the dependent variable. So let's plot the points. 0 children, 1 box of cookies. 1 child, 3 boxes of cookies. 2 children, 4 boxes of cookies. So if we wanted to draw a line of best fit on something like this, which we did a lot in the last lesson, it would have to be dashed because they're only selling whole number boxes of cookies, and we're only talking about whole number amounts of children. Sometimes if you're taking like population averages, you might end up with a decimal number, like the average house has 2.3 children, but in general we keep whole numbers for people and animals and things like that. Okay, so it appears that as the number of children are increasing, the number of boxes bought is also increasing. So there is a relationship here. However, is this enough evidence? They've only visited 3 people and they've based this entire conjecture on that. It is not enough evidence. So to answer the question, is Leia's conjecture supported by the data? Yes. Her conjecture was families with more children buy more boxes. Yes, her conjecture is supported. But we need more data. Okay, next question. Alim's conjecture. People who make a higher income are less likely to take public transit. So Alim speaks to a few people and has some data here for us to graph. So income in thousands of dollars, 23,000, 27,000, all the way up to 87,000. Public transit usage per week, 18 trips, 4 trips, well, 0 trips, 4 trips, 14 trips, 0 trips, 22 trips. Okay, sketch the data on a scatter plot. So we have a scatter plot set up right here. What is going to be our independent variable? Well, let's do the income for the independent variable. Remember to include the units, it's thousands of dollars. And public transit usage per week. Okay. So for a scale, on the income we have to go from pretty much 0, close to 0 to 87, and we have, I think, about 20 spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, there are 20 spots, so maybe we'll do a little 20, so each one needs to be worth about 4. Let's make it worth 5. So let's go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Okay, not bad. And then the public transit usage is up to 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 here. Let's go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so our first income is 23,000 and they're taking the bus 18 times. Oops, right there. Then 27,000 and 0. They do not take public transit at all. 34,004. 46,014. 58. 0. 87 and 22. Okay, so what can we see from this? Can we see a bit of a pattern? Does it seem like the more money people make, the less they use transit? The more money people make, the more they use transit? Doesn't really appear to be a pattern at all. So if there's no pattern, does it support his conjecture? We could say no. The data does not support his conjecture. Because there's no pattern. So make sure you write this in your notes. We could probably use more data. And maybe if we polled 1,000 people, we might see a trend. Or we wouldn't say trend in this case because it's not over time. We would see a pattern.